Hi, my name is Hari, and I'm incoming senior going to Mission San Jose High School. For my intensive project, I picked object detection using Raspberry Pi. So the way I went about this project is I split it up into three sub-projects, and the first one was using the Raspberry Pi object detection. So the way I went about this was first downloading the required packages, which was TensorFlow Lite and OpenCV, and then I downloaded the pre-trained model. The reason I did this was TensorFlow Lite is tuned more towards devices with lower power and lower battery, which is the Raspberry Pi, and it mainly runs on pre-trained models, so that's what I use for this project. Then I had to connect my camera to the Raspberry Pi, and then I ran the pre-trained model. So here's a demo of my first part. So the way it works is it detects different objects, like around 80 different objects, which are common, such as like cars, people, chairs, backpacks, water bottles, and stuff like that. And one of the biggest challenges I faced throughout this process was the camera is something I had to hold manually for most of the time. So I decided to CAD a stand in a case for the camera, so it would be easier to place the camera and put the objects in front of the detector. So then, for my second sub project, I created my own custom object detection model, which I trained by myself, and it was a model which could detect between three different types of classes. One was an SUV, the other one was a sedan and a pickup truck. So the way I did this is first I downloaded a data set of 300 different images from Google, and then I labeled the images by myself using a software called Label IMG. So the way I labeled images was first creating bounding boxes around each of the different types of cars, and then entering whether it's a sedan, pickup truck, or SUV, and then I had to export these bounding boxes using a text file. I did this in the YOLO V8 format, which is a common object detection algorithm. And the way this format works is there's five numbers for each bounding box, and the first number is the class number. So since I had three different classes, it was 0, 1, and 2, and these correlate to the class name, which was SUV, sedan, or pickup truck. And then the next four numbers are the coordinates of the bounding box. And then I had to create a third file, which is a YAML file. This file will correlate the numbers, which were the 0, 1, and 3, the class numbers, to the class name. So SUV, sedan, and pickup truck. Then I uploaded all three of these different types, the images, the YAML file, and the text files to Google Drive. And then I used Google Colab, which is a Python IDE, which already has an inbuilt GPU and TPU, so it can train the model faster. Then I ran the code to train my model, and here is the demo. So one of the biggest challenges that I faced throughout this process was labeling the images, which took a lot of time and patience because I messed up around 5 times, so I had to label the images around like 1,500 times in total. But overall, I realized that I need a lot of patience for this, and if I had patience in the beginning, then I wouldn't have to label it these many times. So here are the results here, and as you can see, it's fairly accurate, but one thing I noticed is it's sometimes not too accurate when you show the car from the front side, as it's much more difficult to differentiate between cars from the front side than from the side, because like the height factor and the like for pickup trucks, there's like a place where you can put your like a big trunk in the back. So that's one of the biggest challenges I faced. And then for my third sub project, I created a custom license plate detector, which will basically detect license plate if you upload an image to this. And the way this model works is I again coded it in Python in Google Colab, and I used the main two packages I used were OpenCV and EasyOCR. The first one is, again, it just takes the image into the model, and the second one is the optical character recognition software, which will convert the text inside an image and will output it as text. So the way this works is first I upload the image into Google Colab, and then I convert the image to grayscale so I can take out the factor of different colors and the brightness of the colors. And then I use edge detection and noise reduction so we can get like a more defined shape inside the picture. And then I check whether there's 4 points to see whether or not we can classify it as a rectangle, which correlates with license plate. And then if it has 4 points, then we think it's a license plate, and then we run through the rest of the program, which will then crop out the image and then blacken out the rest of the parts, and then use the optical character recognition software to convert that text inside the image and output it as text. One of the biggest challenges I faced throughout this process was not having text outputted actually. So what I did for this was making sure that the 4 points actually had text within it, because sometimes it would detect just random objects which are part of the picture, and there would be no text outputted. So here's a demo of the project. And one reason which I couldn't do a live demo for all of these was because all of these would take like a lot of time to run, because most of these models have to be trained live. So that's one reason I couldn't do a live demo. But as you can see here, there's the license plate, which is CCC444, and the number over there, which is 0.7146, is like the confidence of how confident it is that that's the correct license plate. Again, there will be some errors sometimes, like due to like brightness factors and stuff. But as you can see here, this is the license plate right here after it blacking out the other parts. And one thing I learned from doing all these projects was to have patience, because I would have saved a lot of time if I had more patience. And I also learned like different machine learning techniques, such as image detection and how to use computer vision and different packages to detect objects. And next, I would be trying to explore other topics in ML and AI, such as like NLP and like generative AI, and try to do projects in those areas. So yeah, thank you.